which is going to be conditional execution. So conditional execution is a fancy way of saying how to make your programs contain some logic. So more or less all the real functionality that you see in computer programs is done by using some sort of conditional operations. So if we take this example of the web browser once again, so for instance, the user has the ability to give inputs like type in website names to the address bar. Well, then that's all very nice and neat, and we already know how to handle or process some of those inputs, which was the topic last week in the lecture and in the exercises. But going further beyond this, how to just process the input, how would we be able to do something? How would we be able to change the program's state based on that input? So, for example, in our browser example, how would the browser know what website to go to? Clearly, this is something to do that's based on the written input, but still the program has to do something. It has to figure out what to do based on this input. So user input is one of the keys that you can use to make a program that reacts to whatever the user is doing. So you remember this picture where there's the user, you or one of us behind the keyboard. We are typing stuff or moving the mouse, or in the case of a touchpad, we're doing gestures and clicking on things. And then based on that, this program does whatever it is that it does. If it's a word processor, it processes words. If it's an internet browser, it browses the internet. And usually there is some visible output to your input. So that's what this output in this cycle denotes. So you will probably be able to see a visible change in the program and its state somehow. So whenever you click a button on the user interface, it probably does something. So the input is followed by some processing, and then you see some sort of output from the program as well. So basically, to continue this idea, that so far this is all great, but what's still missing, and what is missing is the idea of making our programs smarter and smarter. So far we've just been processing input, but what if we wanted to do more and more things, more complex stuff? So all of this program logic stuff that we need to do is done with conditional statements or conditional program structures. And by definition, this sort of conditional statement is a program structure that can be used to alter the sequence of execution in the program. So when you type program code into the code editor and then you press F5 to run this program, then all of those instructions are completed. They are run. Each individual line of that program code is executed and something comes out. But what if, depending on some condition, so let's say we have some condition X, we might want to do different things. So for example, if it is morning, we want to make a program that greets the user by saying good morning, and if it's afternoon, the same program would greet the user by saying good afternoon. or good evening respectively if it's even later. So here X, the condition that you might use to make some logic, this could be it could be user input. Most often it is some user input, so we expect computer programs to react to user input when we do something on the computer, be it a key press or you move the mouse or whatever. But of course, the condition could be something else like the time of the day, or might be some cosmic radiation measured from outer space. Might have to do something with global politics. Don't know. Okay, well, these two latter examples, cosmic radiation, North Korea has some conditions to do something, maybe extreme examples. So because usually the condition needs to be somewhat deterministic, and deterministic in computer terms means that something is predictable. So we preferably want predictable conditions that we can react to. So for example, this time of day, if it's before noon, we know it's morning. If it's before 6 p.m., we know it's somewhat afternoon. Conditional statements are also called if statements. And when we get to actual programming, or well, if you look at the example below, you will very quickly discover why. So if we get on with actual coding again, I think the best way to illustrate how a conditional statement works is to just take a very simple example. So if I will bring up the programming environment once again, I've opened a new file for the codes this week. So let's say we are doing a program that mimics whatever happens when a user logs into their computer. So when you log into your computer, you need to type in a username or at least a password, or how you open up your mobile phone by typing in a PIN code or a password or whatever. This is a very real use case because of the examples that I just mentioned. So this sort of code might actually be something that you use daily. Maybe not in maybe this is a bit of a simplification that we do right now, but this sort of checking for a passcode or a password or secret PIN code or something is a very actual example of what kind of code all of your computing devices or mobile devices are running right now. So to begin with, we need to ask for some user input. So to begin with, let's ask the user to enter to type in a password, and we're going to store it in a variable that's just going to be called password. And then we add some logic to this. So let's say that for a particular password, we are going to let the user in to this program, and for all others we're not going to show anything. So this is sort of a password check in its bare essence, how a password check might work. So what we need to do now is to check what this password input has, what the user typed into this password input. So we do that by saying, so if the password is equal or contains, and let's say our secret passcode would be secret, just lowercase secret. And if this happens, then we say, well, let's say access granted for the system or this code, signifying that the password was indeed correct. Like so. And this is more or less the basic way of how to make a conditional statement. So we have a condition which is here on this line starting with if. That condition is if this variable password is equal to this text, which this text being secret, and if and only if we then print this line access granted. So if we now see how this program works, I'm just going to press F5 to run this program. Okay, we see here the prompt, enter password, and if I enter this secret password, well, you can see it's not very secret because we can see it here on the screen. Usually you wouldn't see passwords on the screen, but that's one of the reasons why this is just a illustrative example. I'm just going to type in the secret password here and press enter. And the program says that access is granted. So this secret password was correct. If I run this again to see what happens if I type in an incorrect password and press enter, we can see that nothing happens. So this is really the gist of the conditional execution, how to provide some simple logic to how to make your program do intelligent stuff. And really all intelligence that computers have they are more or less just based on this if some condition, then do something. That's really all it is. I mean, perhaps maybe you will run into something like artificial intelligence at some point, if you have ever heard of this term, or something called machine learning. Those are more advanced ways of creating something that looks like intelligence, but it's not much more than just these glorified if statements. So to say. Of course, there's a little bit more science and intelligence behind it, but really all logic that computers exhibit, at least these modern computers that we have had in the 20th century and 21st century now. For these, all the logic is pretty much done with these conditional statements, or well, everything that you could imagine that should be done could be done with the conditional statements. Okay, so notice a couple of things about how I have written this conditional statement. So we start with this keyword that's called if. If is preceded, if is followed by some condition. And there is a bit of a science, or well, technique to how to write these conditions. But in our case, this condition means take this variable called password and compare it to this piece of text, secret, and notice these two equal signs here. So if we want to ask for is this variable equal to this piece of text, we need to use two of these equal signs. So writing it with just one equal sign like that, well, this is incorrect. This, if I try to run it, it's going to crash on this line. If I try to do that, I will demonstrate. It will say, okay, this syntax is invalid because this single equal sign here is out of place. So only when we are doing an assignment to a variable can we use this single equal sign. Now, if we're doing a comparison, then we need this double equal sign. So that's just something to keep in mind, and it's something that often people with no prior programming experience get wrong. So in a comparison, there's two equal signs. If you need some sort of like mnemonic or memory device to remember this, just remember in this conditional statement, you need to use as many equal signs as you have wheels on a bicycle. And that's this memory trick actually has some hidden meaning in it. So in Python and in many well, most of programming languages, when we are doing a comparison, it's done with this double equal sign operator. So you almost always use two equal signs. But there are some weird programming languages, and by weird I mean really weird, where this comparison is done just with one equal sign. So if you have ever heard of a programming language called Pascal, that would be one of those weird things. So then you would imagine that the weird circus clown who rides around in a unicycle, well, that guy is writing their program code in Pascal. Well, anyway, I digress a little bit. So now that we've run through this example, let's continue with it. So what if we wanted even more logic? So let's continue it like this. So here we are. So in this example now, if and only if we typed in a password, a secret password that matched this text secret, we would get this end result access granted displayed on the screen. But in this case that we entered an incorrect password right here, nothing happened. So perhaps we would want to display a message if nothing happens as well, together with this correct password. So that would be done with another statement that goes together with the if, and that's called an else statement. So here, how you would read this is basically if a password is secret, then we print this line, and else, meaning in all other cases, we do something different. So let's print something like no access in this case. And let's see how this program now works. Okay, so we enter a password. If it is correct, we should still see the access granted message. It's good. And if we type in an incorrect password, we should see a message displaying no access. So that's so great. So now we have added a bit more of this logic. And something else to take away from this example, notice how these print statements that are inside this code block underneath the if, it's indented to the right. So that is for a reason. So everything that is indented now belongs underneath this if clause. Similarly, everything that's indented belongs inside this else statement. And basically, the idea here is that everything that's indented, we want to happen based on this condition that we wrote here. But if we want to continue the execution of this program, then we need to undo this indentation and continue from the beginning of the line again. And you do this indentation with the tabulator button. So if we then want to display some sort of message at the end of the program, we would do something like let's say this is a message that simply signifies that the program has ended. Let's do something like program ends here. So if we now look at how this example works, let's begin by typing in the correct password here, pressing enter. And I actually inadvertently started by misspelling it. So we got the wrong password. So we got the no access message here. But then here where we stopped indenting the text, we moved this back to the beginning of the line all the way to this left side of the screen. You can see this program ends here comes after whatever logic was here. Similarly, if I try to run this again and I try to spell secret correctly this time, you can see even though we display this access granted message, we get this same program ending message at the end, just the way we got it the last time, simply because this line, this print is no longer, it no longer has anything to do with this conditional statement. So only things that go inside this conditional statement have anything to do with this condition, and how you signify that is by indenting the text. And the indentation is done with the tabulator button. Alternatively, you can type in four spaces instead of the tabulator. That's usually how you indent text. Okay, moving forward. So if we take another example to illustrate a little bit of what these conditions could possibly be. Well, in order to know this, we have to read up a little bit on the documentation of what we can do. And it turns out there are about 6 different conditional operators that we could use together with this if statement. These are basically this less than operator, greater than operator, less than equal to, greater than equal to, the equal to, and not equal to operators. So if we take this example from the left here, we should be able to do another example, this time having to do with the time of the day. So let's do that real quickly. So we get rid of this previous example and we start with a new one. Okay, so this example was the time of the day. So first of all, we start with user input. So we just ask what time is it, and then what we do, because this input is text, and probably in order to make comparisons, like something like is it earlier than 12 or later than 12, we probably those sort of comparisons, what we saw on this slide, these less than, greater to, only make sense with numbers. So we have to make a conversion from the input text to a number. So the time is really and I'm reusing this time variable here, as shown a couple of lessons ago. So we want to just use this int command to convert whatever was in this time variable to an integer. So we're presuming that the time is just going to be a full integer number, so it's just going to be the hour. So the time will just be 10 or 11 or 1500 hours. We're not going to bother with the individual seconds or minutes this time, because this is just an example of how the conditionals work. We don't need to implement the full clock phase for this purpose. Okay, so then let's make the necessary conditions for this sort of program to work. So we want the program to greet us with, and let's specify, I'm just going to type in as a comment these conditions so that we can follow the example a little bit easier. So if it's earlier than 12, say good morning, and if it is or actually if it's 12 or later, say good afternoon. And I'm not going to bother with something like evening at this point. Oops, that's not going well. Okay, let's restart the screen share real quickly. Sorry about that. That's not exactly gone to plan. So let's share screen one again once more and see that it actually also works. Here we are. Okay. Right. So now that my screen works again, let's do the actual condition here. So I'm just going to say if the time is below 12, we are going to do this good morning greeting. And now we could do the next bit the same way. So well, we could do the next bit in two different ways. If we start off with the previous example about if and else, we could just do, since we only have two conditions, it's going to either be earlier than 12 or later than 12. So we could just do if and else. Well, let's test if the program works now. Okay, let's say it is 10 o'clock in the morning. It should say good morning. Okay, let's test again. Let's say it's exactly 12. It says good afternoon. Finally, something that's in the afternoon, let's say like 1700 hours. Oh, not 17,000 hours, 1700 hours. Actually, it's just 1700 hours, like that. Still good afternoon. So it all works. Okay. We could alternatively make this second condition work on its own as well. So again, so this condition here works separately from everything else in this program. So we had this input and data type conversion here. That will always come first, and it has nothing to do with this conditional here. Similarly, if we just write out the second condition, this if the time is 12 or later, say good afternoon, as its own if clause here. So that means time is greater or equal to 12, and then we say afternoon. And we should get the same result. So let's try this in practice. What time is it? It was 10 in the first. Okay, it's morning. Let's try exactly at 12. Good afternoon. Okay. And the final test was at 1700 hours. Still afternoon. So the point of this basically, if we have only two routes that this condition could go, we could write it as an if-else. But if these conditions are independent of each other, then we can also write them consecutively in their own if clauses like this. This is probably the easier way to do things. If you think about it, these are fairly independent conditions. It's not the time is never going to be in a state where it's both less than 12 and greater than 12 at the same time. So this works because of the because of the context. Okay. So what have we covered here? We've covered some of these conditional operators. So we covered this less than operator. The greater than operator works the same way. We used this greater than equal to operator in the second if clause. The less than equal to operator works the same way. And of course, this equals to operator we already saw in the password example. This not equal to, so exclamation mark, an equal sign, basically it's just the opposite of the equal to. So if some variable does not match some piece of text or some number, then you would use this one. And again, notice the indentation inside this in this code block that goes together with this condition. Okay, so this all seems pretty simple. So a conditional line starts with the if keyword followed by some condition. So in our example, the first case was to test for is the time less than 12. The same idea applies for the second example case as well, with this greater than equals operator doing pretty much the same as the less than operator, but it just works in reverse. And you always end these if and else lines with a colon. So there is always this colon sign at the end of that line, and if you forget this colon, the editor will say once you try to run the program that you have used invalid syntax. And of course, the next line, the print lines in our example, form the conditional code block which we want to run. And we always run this code block if the condition is true. That's to say, if the condition matched the given rule. And notice that this block really needs to be indented. Otherwise, it will not be tied to the same to this if clause in any way. And in the worst case, you might end up with another invalid syntax message. Okay, this I think we covered already. So if you put another print statement at the end on the same level where this if statement is, then this last print statement is always executed at the end of the program, no matter how this conditional statement here was evaluated. So no matter if the time was less than 12 or not, this print statement always gets run anyway. So this will always be at the end of the program. So if you want to jump out of the condition block, you just remove all this white space on the left. So you stop writing stuff that is indented to this level. Okay, another thing. So in the previous example, we put these if statements one after another, but it's also possible to write these in a way that they are nested. So one if statement can go inside another one. So basically, we are saying if this and if something else, then we do something. So to illustrate, let's put something inside one of these code blocks. So instead of more input, I'm just gonna write here some extra information. So I'm just gonna make a new variable that's just going to hold the word yes inside. So we're gonna do a little bit of extra logic inside this time example. So if the time is earlier than 12, we're gonna do this greeting at first, and then we follow with some more logic. So we're gonna do another check for some for a condition. So if the time is earlier than 12, meaning it's morning, and if we are tired for some reason, maybe we have stayed up all night, then something else happens again. So and we have just preset this tired variable to contain yes anyway. This could be another user input. I'm just putting it as an extra variable that I defined the text inside it just as an illustration. So this could be done with a user input as well, of course. So now this logic sort of follows the pattern of, okay, if the time is before 12, and if we are tired, we just we greet the user by saying good morning, go grab some coffee. if we were not tired, this would not be printed. And of course, if it's not morning, we don't greet with this good morning statement at all. So let's try this out. So first of all, let's see what happens if it is early in the morning. So let's say it's 9 o'clock in the morning. The program will say, good morning, go grab some coffee because you are tired. If it happens to be afternoon, like 1400 hours, we just get a greeting of good afternoon. And if we were to change this tired variable, well, its contents to something like no. And in this case, even if it was early in the morning, let's say really early in the morning, like 6 in the morning, and we try to run this, all we get is the greeting of good morning, but no need to grab any coffee because we are no longer tired. So this variable doesn't contain the word yes, so this line will not be printed. So the point of this, you can put multiple if statements, or we can put one if statement inside another one. These are still very independent. It's just that this if statement is only run if we ever get inside this outer if rule or if condition. So only if the time is prior to 12, then only then we get to this line to evaluate if this condition is going to be true or not. Okay. We could do this another way. There is also a way to nest these conditional operators by using the AND keyword. So saying something like if the time is prior to 12 and the variable tired is equal to yes. So then we could have another message printed. So we could do that, for example, by modifying this if statement a little bit. So what I'm going to do is I'm going to move this all the way to the left. That you can do by saying format and didn't region. So we're going to do well, actually, let's get rid of this whole region because it's no longer needed. So if we want to just unite several different conditions, we can put them inside this one if statement by using the AND keyword. So we would put something like if the time is earlier than 12 and tired is yes, then we would say good morning, go grab some coffee, you look tired. Now notice that this change to the program is now going to affect both of these conditions. So what this AND keyword means is both these conditions, this time is earlier than 12 and tired is yes, have to be true in order for this line to be printed. So if I try to run it now, so right now time is something we can input and tired is set to no. So if I run it now, we say it's early in the morning, like 6, press enter, you see nothing happens. That's because this second condition here, tired equals yes, is not going to be true because here you can see tired is set to no. So it's only if I set tired to no, only if I set tired to yes, that both of these conditions are going to be true. So if I now run it once again, let's say again 6 o'clock in the morning, now it prints the statement because both conditions are true. So if you put in multiple conditions in the same if statement, then you really must make sure that all of them are true before anything inside this code block is run. Otherwise, the program just jumps over all of this code because these conditions are not true. Right. Okay. One word more about data types. I know I have talked a lot about them, but well, the thing is, previously we said, or it said in the presentation, and I think it says in the website as well, that there's only two data types. There's numbers and there's text. Well, that turns out to be a lie. Very good reason for this lie. It's probably easier to just deal with numbers and text to begin with. But once we are starting to deal with conditional statements or conditional code, then we need a third type of data type. So there actually happens to be more than just two types of data. We won't even be able to cover all of them during this course, but just be aware that there's more. And the third data type, that's something called a Boolean value or a truth value. So let's consider these conditional operations, something like 1 is smaller than 2 or 2 is smaller than 1. Maybe let's put one of these, or maybe both, in the interpreter and see how they are evaluated to figure out how this third data type works. So I'm just going to pull up the interpreter here. Not going to get the code editor, just the interpreter, because this will give us a result immediately. So if I type in something like 1 smaller than 2 and press enter, what the interpreter gives me is the answer to this is true. If I do the same with 2 smaller than 1, which obviously is untrue, and I press enter, the interpreter says that this is false. Now notice that it didn't give me some sort of like 0 or 1 answer. It gave me just words true and false. So these true and false are types of data that you can assign to variables. So these conditional operations, these once the interpreter works out if this condition is true or not, these statements result in either the values of true or false. So they are data types that you can also assign to variables. So there is also a way of writing something like we have a variable called condition and it's true. So its value is true, and then we can evaluate if this condition has the value of true, and then you could print out the result. And if we do that in practice, just to prove that true is always true, not sure how meaningful that is, but we can do that. Okay, so now we set out to prove if true is always true. So we have variable called condition, and we can set a value for this variable which is true. And then we can do an if statement or if clause to check what the what the content of this variable is, and we then check it against value called true, and here we are. To say something like condition was true, meaning the content of this condition variable was true. And if I run this program, you can see that we get this result because we did enter this if statement here, because this contents of this condition variable were in fact true. If I were to change this to false and rerun the program, we get nothing as a result, because this comparison between condition and true is no longer true. So condition is false, and false is not the same as true. Actually, you can write this same in a shorter way. So it turns out, because these conditional operations, such as the greater than, less than, equals to operations, end up with these true and false values anyway, what you can do is you could just write if condition. You don't have to especially say if condition is true. Everything that you put always in an if statement needs to be either true or false. So you could just say if condition, and just to prove that the program is still working, I'm just going to change this value as well. So you could also say if condition. This means the same as if condition equals true, as you can see here. And one of the less probably more unintuitive ways to write this would be just to say if true. This is perfectly legal to say this. We don't even need this condition variable anymore. And if I run this program, it will still print this line. This line, because it just says if true, and it doesn't even say if, it doesn't even ask if something is true. It just says that something is true, and if well, it just says if true. So basically this is the same as just having this print statement. We don't actually need this if clause here. But there is an interesting application to this kind of a always true statement that's going to be presented in the next lecture. So this is just as a heads up toward the future. So this is something that you can do. It may not be apparently obvious as to why you should do this, and probably you shouldn't do this right away like this. So you wouldn't do this normally, but you can. Okay. So let's continue with our time example once more. So let's put some more logic into our program that greets people based on what time it is. So let's ask again what time it is. What time is it? And we convert the time to a number again using the int command. And let's start with what we had to begin with. So if time is less than 12, you print good morning. Okay. Then let's continue. Let's putting more logic to this. So let's say that we want the time that's between 12 and 1900 hours to be somewhere in the afternoon. So we would say the time is smaller than or less than 19. We would say this is now afternoon. And following the same logic, we might say if the time is if it's not before 12 and it's not before 7 p.m. Maybe it's still before midnight. So in this case, we would say something like good night or good evening. Let's say good night for now. Okay, let's test if this works. So let's say it's 8 p.m. in the evening, so it's 2000 hours. Says good night. That works perfectly. Let's say it's 6 p.m. so 1800 hours. Well, that's not quite gone as planned. It said both good afternoon and good night. What happens if it's 10 in the morning? Well, this really has not gone to plan. It can't be both morning, afternoon, and night at the same time. So the trouble with this, with using individual if statements, is that they are really independent of each other. So in our case, let's say time was something like 9. Well, 9 is less than 12, it is less than 19, and it definitely is less than 24. So all of these conditions apply at the same time. Yet in our example, I mean, it cannot possibly be morning, afternoon, and night at the same time. So how would we choose just one of these? So it doesn't work if we just put multiple if statements one after another. This is not a very good way to to program this kind of an application. So let's try to improve on this. So maybe we could try to take into account the different states that this time could possibly be in. So let's add something like, well, for anything before 12, it's always just going to say good morning. And let's maybe say, okay, if the time is before 19 and it's not before 12. So not is another keyword that you can use to specify the opposite of something. So while we could say if the time is before or less than 19, but greater than 12, I've spelled that out as time is less than 19 and time is not less than 12. Similarly, I could say if the time is less than 24 and the time is not less than 19 and the time is not less than 12, only then we would say good night. So this way, using this and this and keyword and putting multiple conditional statements into the same condition block, we could make this logic more infallible. However, well, this will all work. If you want to copy this from the slides to the code editor and try it on your own, this will work. But it seems very complicated, and it turns out actually it not only does it look complicated, it is complicated. So maybe there is some better way of achieving the same logic than just putting more and more restrictions into this code. So we already saw this if-else logic in one of the examples. So this is what we're gonna more or less use in our advantage to solve this time problem. So if-else statements are basically to say, okay, we have one conditional statement here, and this line is executed only if and only if this condition is true. And in all other cases, we do something else. This is the logic with the if-else pattern. If and only if, or conversely, what happens in all other cases. Well, if we look at the example on the previous slide, we had three individual lines here. So morning, afternoon, and night. So if we wanted to represent three states, morning, afternoon, and night, with just if and else, that would be a bit tricky because there is, well, we could do if it's morning here and else, but then we would be losing or like merging the afternoon and night together. Or maybe if we did if for it being night, then else would have to merge morning and afternoon. Now we could, as shown before, use more logic inside this else statement. So we could put the extra conditions inside the else statement as well. That would be possible. But it turns out there is an even better way. That better way is a structure called if, elif, else. So how this would work basically is something like the following. So we ask the same way what time it is and convert the time to an integer number. And then we ask the first question, is it morning? This far, everything goes the same way. Then we need to find a way to put these this if statement, that if statement, and this last if statement to work together. So for that, we need in between here a statement called elif. That stands for else if. And finally, we're going to substitute this last if for an else. So basically saying, okay, so else if it is not afternoon nor afternoon or must be evening, like that. Okay. So now what this if else structure will do, it joins these previously independent conditional statements together so that only one of these branches is ever executed. And if we run this branch, then the following ones are no longer no longer executed. So these are no longer independent. So if we go into this first if statement here, we never go into the second one. If this first if statement turns out to be false, then we evaluate the second one, and we might go into this code block. And finally, if neither of these preceding blocks, if neither of these conditions is true, we then jump into this else branch. Now, let's see if this works. So what time is it? Let's say 9 in the morning. Says good morning. So far so good. 1300 hours should be in the afternoon, as it seems to be. And 21 or 9 p.m. in the evening should be in the evening, so it says good night, and now it suddenly works. So what the if else structure does, it specifies an alternative code paths. So if the first condition is not true, we then test the second condition within this elif, and finally comes the else section. Note, however, that I've written this out as an if else, so that there is like 3 different branches you could go to. This is not the number of branches does not have to be 3, however. You could leave this else part out, or you could put 2 or more elif statements here in between. The only restrictions here is that you have to start with an if, then the rest of these are voluntary. So if you start with an if, you can pair it with an elif statement, and you can end this whole thing with an else statement at the end. But the else is not mandatory, neither is the elif, and you can have multiple elifs if you want to. So let's say we wanted to partition this to early afternoon and late afternoon. We could definitely put 2 elifs, one after another. So maybe something like before 1600 hours and before 1900 hours, for instance. Something that's important to remember about the conditional operations and how we deal with input. So let's have one last example of how to ask for input and to check for what that input contains. So let's comment this one out once more. Okay. So let's write a program that asks for the user for their name. And then we do a little bit of checking. Let's say this is again having to do with logging into the computer or something like this. So we might say, okay, if we recognize this username, then we do something. So if we recognize this user as Donald, we're going to greet them as hey there, Donald. And because we know a couple of people named Donald, let's presume they are either the famous Donald Duck, or maybe a president of some sort. Okay. And if we don't recognize this, the username, we add a else statement here as well. Say, hey there, stranger. And say something like, I don't recognize you. But nice to meet you anyway. You are. Okay. So here, and let's run this once or twice to figure out how it works. Okay, so let's say, what's your name? My name happens to be Timo. And of course, this program does not recognize me because, well, I didn't program this name Timo into the logic here. So it says, hey there, stranger, don't recognize you, but nice to meet you anyway. Let's try the other path. So what's your name? Let's use Donald this time. And now it says, okay, hey there, recognized you. Are you the famous Donald Duck or maybe a president of some sort? So basically a very simple example of looking at what the user has typed in. So if we know what the user may have typed in, you can use an if statement to check what it is. So if you ask the user to input a word, and you might have a guess of what that word is, or maybe you have even asked the user in this input prompt to either to choose between an apple and a pear, then you might do if the choice was an apple or if the choice was a pear, and you could construct some sort of logic for the program. Anyway, this is all very easy. It's an easy example to understand because we deal with names and texts, because the names are essentially just text. So this will always work. This is very hard to get wrong. However, the one thing that you often people with little or no prior programming experience do get wrong is once we move away from text and names and we start to play with numbers instead. So let's, as an example, make a number guessing game. This is going to be a very simplistic game. So it's basically just going to be a game where you have to guess some pre-programmed number. So let's make that number guessing game as the last example of today. Okay, so we start with this is the number guessing game, and we take the guess as an input from the user. So guess equals input. And we're going to tell the user to guess a number. And then we're going to do the actual logic. So we pre-program secret number. So the logic of this number guessing game is that anything that is not the number 2 is incorrect, while 2 is going to be the secret number. So let's program it like this. So if our guess is 1, we're gonna do well. Actually, let's be a bit smarter about this. So let's pre-program the secret number, which is is 2. Okay. So if the guess is 2, we just say that was correct, and you win the game. Okay. And in all other cases, we say, okay, else that guess was incorrect. Please try again. Here we go. So now let's see how this works. So we run this and let's guess a number. Let's guess something like, I don't know, 42. And it's incorrect, of course. Please try again. And we already know the secret number is 2, but we're just playing with this. The same goes with any other number like 9 or 7 or whatever. Let's try the correct number for a change. So let's try 2 and press enter. And we're greeted with the message incorrect. Please try again. So what's happening here? So we used the correct number here, 2, but we still got the wrong message. So this logic did not work. Well, the reason this logic doesn't work is because remember that input gives us always text, and our secret number here is a number. So what we have to do to make this work, we have to transform this text input, the number that comes as a text input, into an actual number using either the int or float command, either one of the int or float commands like this. Now if we run this and we choose the correct number, we win the game. The point of this is basically 2 and whatever is the text version of 2 are not the same thing. So make sure that if you have a comparison that you also have the data type correct. Are you comparing number to a number, or are you comparing a piece of text to a number? And if it is the latter, this condition will never work because numbers are different from text. And it turns out for all the possible data types, if you try to compare different data types with each other, Python will allow it. It will not say that there is something wrong, but you will never see why this comparison has failed. So again, numbers are not the same as text, and always when you get input, it's always text. It's never directly numbers. You have to convert any text inputs to a number using the int or the float command, respectively. Right, that I think concludes the material for today.